1. In 1961, NASA released a report titled Calculation of Wind Compensation for Launching of Unguided Rockets, which described their attempt to find a method for calculating wind compensation for unguided missiles and rockets to find their targets. Page 8 of the report reads, "This simulation assumes a vehicle with 6 degrees of freedom and aerodynamic symmetry in roll, and the missile position in space is computed relative to a flat, non-rotating Earth." On page 11, the equations that follow are specified as being in the plane of the Earth. Why would a 53-page document dedicated to calculating precise equations for enabling missiles and rockets to find their targets on a spinning globe Earth instead make all their calculations relative to a flat, non-rotating Earth plane? 2. A NASA technical paper published in 1963 called Trajectory Simulation Applicable to Stability and Control Studies of Large Multi-Engine Vehicles described doing computational modeling and analysis of how heavy multi-engine platforms, such as aircraft or large boosters, behave along their flight paths. The report admits on page 6 that a flat, non-rotating Earth is assumed for this study. The Encyclopedia Britannica defines assumption as something that is believed to be true or probably true. The legal definition of assumption from Weck's Legal Dictionary is an assertion of statement that is taken as true or supposed as fact. If Earth is actually a spinning ball, why would NASA assume a flat, non-rotating Earth? 3. The Georgia Institute of Technology prepared a document for NASA in 1965 titled Atmospheric Oscillations, providing theories and equations of why barometric pressure fluctuations happen throughout the day at various latitudes. On page 10, the document states, "A model frequently used is that of a flat, non-rotating Earth," and "the most one can profitably simplify the problem is to consider an isothermal atmosphere, plane level surfaces, and a non-rotating Earth." The document later considers implications and equations for a spherical Earth, but concludes that, quote, "general large effects were better described using the flat, stationary Earth model." If Earth was actually a spinning sphere, all effects, large and small, general and specific, should be better described as such. 4. A NASA document from 1971 titled A Method for Reducing the Sensitivity of Optimal Nonlinear Systems to Parameter Uncertainty details a number of equations and algorithms meant to find the optimal trajectory for a single-stage rocket vehicle starting from rest and going to specified terminal conditions of altitude and vertical velocity, which will maximize the final horizontal velocity. On page 14 of the document, it is admitted that the idealizing assumptions made include a flat, non-rotating Earth. If Earth was actually a spinning globe, and not a flat, stationary plane, surely these complex equations and algorithms for optimal rocket trajectories would have to take this into account. 5. A NASA report from 1972 entitled Determination of Angles of Attack and Side Slip from Radar Data and a Roll-Stabilized Platform stated on page 2 that equations for angles of attack and side slip relative to both a rolling and non-rolling body axis system are derived for a flight vehicle for which radar and gyroscopic attitude data are available. The method is limited, however, to application where a flat, non-rotating Earth may be assumed. This is quite an admission. Why should their method be limited only to applications over a flat, non-rotating Earth? In other words, their method doesn't work over a curved, rotating Earth. If we can only use this information on a flat Earth, and the Earth isn't flat, why would NASA create and publish this useless document? 6. A NASA contractor report from 1978 titled Investigation of Aircraft Landing in Variable Wind Fields, covering equations of motion for the effects of wind on aircraft landings, stated on page 6, the aircraft trajectory model employed in this study was derived based on the following assumptions. A. The Earth is flat and non-rotating. Why does NASA keep assuming the Earth is flat and non-rotating in its technical papers, but keep telling the public it's round and rotating in their press releases. 7. NASA published a technical paper in 1979 titled Development and Validation of a Piloted Simulation of a Helicopter and External Sling Load, all about piloting single-rotor helicopters carrying suspension systems and external loads. On page 2, the document specifies that a general set of nonlinear, rigid body equations of motion for both the helicopter and external load determines the motion of each vehicle with respect to a flat, non-rotating Earth. Later, on page 33, it again confirms the equations of motion for both the helicopter and the external sling load are developed in body axes with respect to a flat, non-rotating Earth. 8. Another NASA technical memorandum from 1980 called A Mathematical Model of the CH-53 Helicopter, filled with complex mathematics for the flying of helicopters, states on page 17, the helicopter equations of motion are given in body axes with respect to a flat, non-rotating Earth. They sure do rely on pretending the Earth is flat and stationary a lot for an organization that assures us it's a spinning spaceball. 9. NASA published a technical paper in 1987 titled User's Manual for Linear, a Fortran program to derive linear aircraft models, which detailed their system for linearizing effects such as net thrust, torque, and gyroscopic effects to aircrafts in motion. On page 16, they specify that, within the program, the nonlinear equations of motion include 12 states representing a rigid aircraft flying in a stationary atmosphere over a flat, non-rotating Earth. So here, it's not just a flat, non-rotating Earth, but the atmosphere is stationary as well. Globe Earth lore, however, claims that the atmosphere around their spinning ball is constantly dragging the entire atmosphere spinning along with it. This is the reason they claim helicopters can't simply hover and wait for the spinning globe to bring their destinations to them, because the entire atmosphere and everything in it, including the helicopter, is being pulled in perfect sync with the spin. So why are their own models and equations assuming a stationary atmosphere over a flat, non-rotating Earth, when NASA claims we actually live within a rapidly moving atmosphere on a round and rotating Earth? 10. The next year, in 1988, NASA published an update to their user's manual with the same title, and again on page 4 admitted, the nonlinear equations of motion used are 6 degree of freedom equations with stationary atmosphere and flat, non-rotating Earth assumptions. Again, how can you assume a stationary atmosphere when the atmosphere is supposedly spinning over 1,000 miles per hour at the equator? And how can you assume a flat, non-rotating Earth when it's supposed to be a rotating sphere? 11. Also in 1988, NASA published a 100-page document titled Derivation and Definition of a Linear Aircraft Model, which, in its opening summary on page 6, states, this report documents the derivation and definition of a linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. In the introduction, it continues stating that this report details the development of a linear model of a rigid aircraft of constant mass flying over a flat, non-rotating Earth. This model consists of a state equation and an observation or measurement equation. The system equations have been broadly formatted to accommodate a wide variety of applications. If they're developing models and making broad equations to accommodate a wide variety of applications, why in the world would their models and equations not assume a rotating round Earth? In their concluding remarks on page 35, they further specify, for a rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. Why is NASA wasting time and money developing these models for a stationary atmosphere over a non-rotating flat Earth if we actually live within a rapidly moving atmosphere over a round, rotating Earth? 12. Another NASA technical memorandum from 1988 was called Flight Testing of V-Stall Aircraft to Identify a Full Envelope Aerodynamic Model, where they flight tested Harrier jets transitioning from hover to conventional flight and back to hover. On page 5, the document confirms that, for aircraft problems, the state and measurement models together represent the kinematics of a rigid body for describing motion over a flat, non-rotating Earth. For an organization that vehemently denies that Earth is a stationary plane, they certainly like to pretend it is for their experiments and equations. 13. A NASA contractor report from 1991 titled An Aircraft Model for the AIAA Controls Design Challenge had similar wording in its admission on page 11, where it stated, "The nonlinear equations of motion used in this model are general 6-degree of freedom equations representing the flight dynamics of a rigid aircraft flying in a stationary atmosphere over a flat, non-rotating Earth." Over and over, these documents do not take into account a moving atmosphere, nor a curved or moving Earth. 14. One NASA contractor report from 1993 titled Approximate Optimal Guidance for the Advanced Launch System, detailing guidance schemes for their rockets, finally does mention an attempt to take into account a rotating spherical Earth. They conclude, however, on page 1 that, since the convergence rate of iterative techniques is difficult to quantify and convergence is difficult to prove, these schemes are not suggested to be used as the basis for an online real-time guidance law. Instead, they admit on page 2 that the problem of maximizing the payload into orbit subject to the dynamics of a rocket in a vacuum over a flat Earth is an integral optimal control problem. They then proceed to use these supposedly simplified yet optimal equations on page 25, where they state the three-dimensional equations of motion are reduced for flight in a great circle plane, the XZ plane, over a flat, non-rotating Earth. 15. Another NASA paper from 1997 called Simulator Aeromodel Implementation presents mathematical models for real-time flight helicopter simulations. For the first several pages, they attempt to develop an inertial axis system for a rotating Earth, but then admit on page 10 that, with the translational equations, one problem is that the body axis is moving along the flight path, and so the position of the aircraft relative to some fixed point, like a runway, is not easily specified. Another problem, or undesirable feature, is the presence of various products involving rotational velocity terms. These terms could cause problems with numerical accuracy when rotational velocities have large magnitude or frequency content. This situation is remedied by transforming to an inertial frame located on the Earth's surface. They then continue the document using equations derived from a stationary plane Earth instead, stating, for the flat, non-rotating Earth considered here, any fixed frame or reference can be employed as an inertial frame. So, once again, when trying to take into account a rotating Earth, NASA just runs into various problems that are better remedied by just assuming a flat, non-rotating Earth. 16. NASA published a technical memorandum in 1997 entitled Predicted Performance of a Thrust-Enhanced SR-71 Aircraft with an External Payload, which looked at using the SR-71 as a launch platform for high-speed research vehicles and carrying captive experimental packages to high altitude and Mach number conditions. On page 10 of the document, it states, the DPS equations of motion use 4 assumptions that simplify the program while maintaining fidelity for most maneuvers and applications: point mass modeling, non-turbulent atmosphere, 0 side forces, and a non-rotating Earth. This seems quite the admission that the fastest and highest flying manned aircraft ever built, the SR-71, can operate fully functionally with equations of motion derived from a non-rotating Earth. 17. In 2002, NASA published another document titled Stability and Control Estimation Flight Test Results for the SR-71 Aircraft with Externally Mounted Experiments, detailing experiments done for stability and control derivatives on SR-71s carrying equipment externally mounted to the top of the fuselage. On page 11, we see once again, these equations assume a rigid vehicle and a flat, non-rotating Earth. The experiments included traveling up to Mach 3, or over 2,300 miles per hour. At that speed, over a spherical Earth of given proportions, a straight and level flight, without adjustment, in just 1 minute, would find itself at nearly 1,000 feet higher altitude due to curvature drop. 18. A NASA study done in 2006 titled Singular Arc Time Optimal Climb Trajectory of Aircraft in a Two-Dimensional Wind Field performed a minimum time-to-climb trajectory analysis for aircraft flying in various wind conditions. On page 2, the document admits, in our minimum time-to-climb problem, the aircraft is modeled as a point mass and the flight trajectory is strictly confined in a vertical plane on a non-rotating flat Earth. Why would all these NASA experiments, equations, and models all strictly confine themselves to a non-rotating flat Earth, unless that was the correct assumption? 19. In 2007, NASA published a report titled General Equations of Motion for a Damaged Asymmetric Aircraft, which detailed how a pilot could survive threats from missiles, mid-air collisions, aging aircraft, and undetermined life cycles. On page 2, they declare, in this paper, the rigid body equations of motion over a flat, non-rotating Earth are developed. The rest of the paper is a series of complex equations and calculations designed for landing damaged aircrafts that should be incorrect and useless without assuming a round and rotating Earth. 20. A NASA article published on their website in 2012 called Robert Simon, aka Mr. Blue Marble, was an interview with their lead data visualizer, who admitted in another interview that his blue marble globe image was, quote, photoshopped because it had to be. In this interview, he admits that the hard part was creating a flat map of the Earth's surface with 4 months of satellite data. Then we wrapped the flat map around a ball. But if Earth is already a ball, why doesn't the satellite data already come in that way? And moreover, why don't the satellites just take an actual photograph for us? There would be no need for NASA's plethora of CGI composite globe images or wrapping flat maps around balls if Earth was actually a globe. 21. A U.S. Army Research Laboratory publication from 2000 called Modeling of Atmospheric Effects attempted to realistically model atmospheric effects and their impacts on the battlefield from smoke, dust, and fog to thunder showers and weather fronts. On page 32, they detail their atmospheric acoustics propagation model called the Scanning Fast Field Program, stating, this model works well over a flat Earth and a non-turbulent atmosphere. In the near future, this model will be added to the Electro-Optical Systems Atmospheric Effects Library. If the point is to realistically model atmospheric effects, why would the government waste time and money modeling a supposedly unrealistic model like the flat Earth? Their model should be made for a spinning globe Earth with a turbulent spinning atmosphere, if that is our reality. 22. A U.S. Army Research Laboratory study from 2000 called Path Loss Measurements in a Forested Environment at VHF looked at designing radar systems capable of detecting objects concealed by forest foliage with antennas of manageable size while keeping foliage signal attenuation minimal. On page 2 of the study, they admit, we made multi-path measurements to provide confidence in the data and to get an idea of how well our measurements of the clearing represented an ideal flat Earth. Later, on pages 10 to 12, they show the expected transmission loss in decibels over a flat Earth and confirm the measurements agree well with the theory. On page 14, they further confirm, after the data were inspected, it became apparent that they tended to agree with the theory given by equation 2, plus some fixed attenuation, and therefore allowed us to develop an analytical expression based on flat Earth theory. They then mention flat Earth again in their concluding remarks, admitting, the propagation loss through woods tends to agree with the theory of loss over a flat Earth. Nowhere in this study do they attempt calculations based on a globe Earth theory, or even mention such. If radars are actually made to function over a curved Earth, studies such as this would most certainly need to take curvature drop into effect, but this is never considered or even mentioned. The only shape of the Earth ever used in their calculations is a flat Earth. 23. A landmark report published in 2001 by the U.S. Army Research Laboratory called Scale Insensitive Detection Algorithm for FLIR Imagery detailed a pre-screening algorithm designed to identify military vehicles and targets in forward-looking infrared imagery. On page 1 of this report, they admit that in scenarios where the exact range is unknown, a flat Earth assumption provides the best estimate. This is quite a revealing admission. If Earth was actually a sphere curving down at a rate of 8 inches per mile squared, surely a flat Earth assumption would not be what provided the best estimate for their range-finding calculations. 24. The U.S. Army Research Laboratory released another research paper in 2001 titled Propagation of Electromagnetic Fields over Flat Earth. This study looked at the interaction of radiated electromagnetic fields in military or law enforcement applications of high-power microwave systems, attempting to find whether the transmitting antennas should be vertically, horizontally, or circularly polarized. Page 7 says, "It is assumed that the transmitting antenna and the target are located above but near the surface of a flat, idealized Earth ground. Tests were done over various ranges and compared principal fields from an ideal dipole oriented perpendicular and horizontal to a homogeneous flat Earth, and concluded that, from the simple, smooth, flat ground model, the vertical polarization delivered the most energy to the target." 25. A U.S. Army Research Laboratory report published in 2002 titled Automatic Target Acquisition for the Demo 3 Program detailed various algorithms and applications for use with unmanned ground vehicles, such as infrared, target acquisition, image sets, and sensors. Page 1 of the report states, "In some scenarios, it is assumed that the range is known to within a meter from a laser rangefinder or a digital map. In other scenarios, only the range to the center of the field of view and the depression angle is known, so that a flat Earth approximation provides the best estimate. Nowhere in the document do they even consider a spherical Earth approximation. If Earth is really a globe, why would a flat Earth provide them with their, quote, best estimate? And why would they not even consider to compare and contrast Earth curvature in their calculations?" 26. A U.S. Army Research Laboratory publication from 2003 titled User Manual for the Microsoft Windows Edition of the Scanning Fastfield Program, version 3.0, detailed an atmospheric acoustic propagation model used for geometrical spreading, refraction, diffraction, molecular absorption, and complex ground impedance. In the abstract for the document on page 39, it is admitted that this model works over a flat Earth and non-turbulent atmosphere. Even with these restrictions, the model performs very well for many scenarios. It seems that assuming a flat Earth isn't really a restriction, but rather a necessity, because in study after study, this is how all calculations are made. 27. The U.S. Army Research Laboratory released another paper in 2003 titled An Energy Budget Model to Calculate the Low Atmosphere Profiles of Effective Sound Speed at Night, where they tested advanced sensors and computer models for the surveillance, detection, identification, and tracking of sound-emitting targets in combat. To examine acoustic attenuation at night, they used low atmosphere profiles of wind speed, temperature, and relative humidity as input to a flat Earth. 28. A U.S. Army Research Laboratory paper released in 2009 titled Computationally Efficient Algorithms for Estimating the Angle of Arrival of Helicopters Using Acoustic Arrays, described using helicopter acoustic signatures as a means of long-range detection and tracking of helicopters. Page 17 says, "The model used was based upon the signal having a single bounce on a flat Earth with propagation that is described by ray tracing for signals in the far field." 29. A U.S. Army Research Laboratory study from 2010 titled Beacon Position and Attitude Navigation Aided by Magnetometer sought to create algorithms for position and attitude estimations suitable for projectiles, munition systems, mobile robots, and autonomous vehicles to use in navigation. On page 3 of the study, they detail the coordinate systems used, all of which are extrapolated from a flat Earth assumption, stating, "The first is the Earth fixed coordinate system, which is fixed to the Earth with a flat Earth assumption." How can these algorithms used for navigating projectiles, robots, and autonomous vehicles be accurate using a flat Earth assumption if they are actually navigating over a globe? 30. Another U.S. Army Research Laboratory paper released in 2010, titled "Adding Liquid Payload Effects to the 6-DOF Trajectory of Spinning Projectiles," tested the behavior of projectiles carrying liquid payloads, such as smoke screens delivered by artillery rounds. On page 7, it is admitted that a 6-DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. These equations assume a flat Earth. Time and again, it seems they are not just assuming a flat Earth, but acknowledging it as such. 31. A U.S. Army Research Laboratory paper published in 2011, titled "Trajectory Prediction of Spin-Stabilized Projectiles with a Steady Liquid Payload," created a method to include the effect of a liquid payload in the flight dynamic equations of motion, enabling trajectory simulations of projectiles with liquid payloads. On page 10, they assert once again that for all the complex equations and formulas that follow, quote, "these equations assume a flat Earth." Once again, is this really an assumption or an admission? 32. A paper published by the Royal Society of London in 1953, titled "Radio Propagation over a Flat Earth Across a Boundary Separating Two Different Media," details a series of equations for vertically polarized radio waves propagated across a boundary between two homogeneous sections of Earth's surface, such as coastlines. The paper demonstrates that when Earth's surface is assumed to be flat, results were valid for the practical application of all examples used. If Earth was really a curved surface dropping at 8 inches per mile squared, such equations for radio propagation should most certainly need to take this into account. 33. A technical report done by Brown University on behalf of the U.S. Air Force in 1955, titled "Review of Sound Propagation in the Lower Atmosphere," was made to address aircraft noise in airports and their immediate vicinities so that acoustical planning could be conducted. The study admitted their sound field data would be taken over several miles from the aircraft and sound sources, but states clearly on page 1 that, in most of the topics to be discussed, the problem is to describe the sound field in a region of atmosphere above a flat Earth. This again begs the question, why would the Air Force not choose to study sound fields in a region of atmosphere above a globe Earth? 34. In the Russian government document "Dissertations Defended in the Scientific Council of the Institute of Physics of the Earth," it is explained how in 1957 the USSR used magneto-electric oscillographs for experimental investigations into phenomena including earthquakes, explosions, and the scattering of light in Earth's atmosphere. On page 19, it discusses using, quote, "a visual photometer of the daytime sky intended for measuring the brightness of the firmament." And on page 20 admits, "The dissertation contains a certain formula of the brightness of the sky, taking into consideration only the brightness of the first order and derived on the assumption of a flat Earth, and giving some conclusions derived on the basis of this formula." 35. A document published by the Naval Postgraduate School in 1961 titled "Propagation Near the Earth's Surface" examines radio and microwave frequencies operating near the surface of the Earth. By using a flat Earth assumption, the author finds that triangulation equations are able to account for signal fading in most cases. The paper later considers diffraction over a curved Earth, but results of this, quote, "smooth sphere diffraction" differ very little from that of knife-edge diffraction over a sharp obstacle on a flat Earth. When the interference regions are compared, their overlaps are so similar that the author concludes that, quote, "there is no simple answer for when we can use the flat Earth formulas." 36. The Iowa State University of Science and Technology published a paper in 1962 titled "The Flat Earth Approximation to the Solution of Electromagnetic Propagation in a Stratified Terrestrial Atmosphere," detailing how using a flat instead of spherical Earth assumption works better for electromagnetic energy propagation equations. The author states that a spherical assumption, quote, "was practically useless from an engineering point of view because of the large number of terms required to approximate the final answer, but that a flat assumption, quote, achieved results which had excellent comparison with experiment." If Earth was really spherical, we shouldn't see flat Earth assumptions time and again achieving excellent experimental results when compared to globe Earth assumptions. 37. A publication by the National Bureau of Standards Journal of Research in 1963 titled "On the Theory of Radio Wave Propagation over Inhomogeneous Earth" attempted to devise formulas for radio wave propagation over an inhomogeneous spherical Earth. The paper claimed their formulas worked over large areas of inhomogeneous ground or large diffraction loss, but were, quote, "poor when any one of these distances is so short that the section is effectively seen as a flat plane. In these cases, the flat Earth or other approximations can be used." Most examples in the paper looked at propagation over the curvature of hills, mountains, ridges, or cliffs, rather than curved Earth surface, however, and did so for both assumptions. The results of the flat Earth assumption were, quote, "surprisingly good," and found in many cases, quote, "the effect of Earth curvature may be neglected and the flat Earth approximation is appropriate." 38. A U.S. Naval Research Laboratory and Department of Defense document published in 1977 called "Experimental Investigation of the Characteristics of PC-1 Micropulsation Propagation Using a Mid-Latitude 5-Station Receiving Network" details how ultra-low frequency geomagnetic waves propagate through the mid-latitude ionosphere. Researchers mapped wave velocity and direction to assess using these natural signals for naval communications. In the document, they compared these waves on a flat Earth versus a spherical Earth. If the Earth isn't flat, why is the Navy and Department of Defense wasting time and money investigating something that supposedly doesn't exist? Why not also do calculations for a triangle, square, hexagon, or rhombus-shaped Earth? 39. An MIT Department of Earth and Planetary Sciences report published in 1984 titled "The Tsunami Mode of a Flat Earth and Its Excitation by Earthquake Sources" studied tsunami generation by earthquakes in a flat, isotropic, elastic, vertically stratified Earth and compared them to those of a spherically symmetric ocean-Earth model. The paper cites 5 previous studies on the subject, all of which but one also relied on a flat Earth model. On page 2, the author states that the spherical results are useful and important, yet it is nonetheless also rewarding to explore tsunami normal mode excitation using a flat Earth model. At the very least, 2 independent solutions of very similar problems can be used to check one another. When calculations were completed, the study found the results in, quote, "excellent agreement" with reality and far simpler than the spherical Earth assumption. 40. A study published in the Journal of Geophysics in 1984 titled "The Relaxation of Spherical and Flat Maxwell Earth Models and Effects Due to the Presence of the Lithosphere" looked at the isostatic adjustment of Earth due to viscous flow in its mantle with respect to both flat and spherical Earth models. The study specifically analyzed the adequacy of flat Earth calculations when modeling the response due to loads of large diameter. Page 6 states, "The most interesting feature is the close match between spherical and half-space flat Earth transfer functions down to very low angular orders." The study looked at huge load scales, such as the Fennoscandia ice sheet and Laurentide glaciation, and found for ranges of several hundred kilometers and more, quote, "the half-space flat Earth approximation is excellent." 41. A MITRE research paper from 1992 titled "Far Zone Field of a Monopole Element on a Disk Ground Plane Above Flat Earth" details the modeling of monopole elements with circular ground planes in proximity to Earth. Using the assumption of a flat Earth for these equations achieved, quote, consistent and excellent agreement of results. The paper concluded that, quote, numerical results for a monopole element with a disk-ground plane above flat Earth are in good agreement with results known from other models. Once again, this study shows how flat Earth assumptions result in both better and simpler experimental results when compared to spherical Earth assumptions. 42. A book published by the French National Institute of Aeronautics and Space in 1998 called The Dynamics of Flight, the Equations, detailed over 300 pages of flight equations. Half of the book is dedicated to equations and calculations which treat the Earth as flat and stationary. On page 7, the author writes, "The first simplification consists in assuming the Earth is flat and fixed. This hypothesis leads to simple equation forms whose validity range is more or less defined by a Mach number lower than 2 for an acceleration error criterion of approximately 1% of the weight. These simplified forms are of great practical use and constitute the second part of this book. If the Earth was truly a spinning ball, why should these so-called simplified forms be of great practical use, constitute half the book's equations, and have such a small criterion of error?" 43. In a research paper published by Pennsylvania State University Graduate School College of Engineering in 2004, called A Discussion of Methods of Real-Time Airplane Flight Simulation, the author discusses equations and methods used for creating real-time modeling and simulation of airplanes. The first two methods described are geocentric Cartesian coordinates and geocentric spherical coordinates based on a spherical Earth, which are deemed inconvenient due to unnecessary complexity. Thus, the author defers mostly instead to flat Earth coordinates and geodetic coordinates, which are simply altitude, latitude, and longitude. On page 10 it states, "Spherical coordinates can be inconvenient for two reasons. First, the geocentric latitude is not exactly the same as the geographic latitude used in navigation. This is because the Earth is actually an oblate spheroid, slightly flattened at the poles. And second, radius from the Earth's center is an unwieldy coordinate." It continues on page 11 to explain, "In many flight simulators, global navigation is not important. For example, the range of flight could be limited to a small area, or the simulator might not care about the airplane's location. In such cases, it is appropriate to model the Earth as a plane half-space rather than an oblate spheroid. The flat Earth coordinate system is a Cartesian system, which originates at the surface. The z-axis points vertically down, the x-axis points north, and the y-axis points east. Thus, spherical measurements are deemed, quote, unwieldy, because Earth is too oblate and flattened for such a coordinate system, and so they recommend deferring to a flat Earth model instead." 44. An MIT Department of Aeronautics and Astronautics publication from 2006 titled A Property-Based System Design Method with Application to a Targeting System from Small UAVs details a Python-based system for use on targeting systems of small unmanned aerial vehicles. In the 250-page document, quote, 3 targeting methods were considered: assuming a flat Earth, using DTED data, and using range data. The idea of using a globe Earth for targeting methods is not even considered. Why does flat Earth always seem to work so well as the default for such a wide variety of real-world applications if Earth is actually a ball? 45. A 2007 study found on the U.S. Navy website titled Studies on Instabilities in Long Baseline Two-Way Satellite Time and Frequency Transfer, including a Troposphere Delay Model, performed by researchers from PTB, NICT, and KRISS, investigated sub-nanosecond diurnal phase variations affecting long baseline two-way satellite time and frequency transfers. In their experiments, they tried 3 mapping functions, stating, quote, 2 are rough approaches, namely a simple plane troposphere assuming a flat Earth, and the straight line of sight through the spherical troposphere shell. The results charted in the report show that averaging the 2 methods assuming a plane troposphere over a flat Earth provided the most accurate path length. 46. A fascinating German University of Bamberg psychological study from 2010 titled "The Earth is Flat When Personally Significant Experiences with the Sphericity of Earth Are Absent" looked at how people's preconceived notions of the shape of the Earth affected their ability to create cognitive maps of Earth's geography. 44 participants were asked to estimate large-scale distances between different cities across the world, which were then submitted to spherical multidimensional analysis with variations in radius. None of the participants actually believed the Earth was flat, but they were all split into two groups, one including people who reported having personal experience with Earth being a sphere, and the other group including people who had no such personal experiences. The people who claimed to have personally experienced the sphericity of Earth gave examples like, quote, "Once, when I looked at the sea, I saw that the horizon was curved," which is impossible since amateur balloons with rectilinear lenses still detect no such curvature even at their peak altitudes of over 20 miles high. Meanwhile, the negative group gave examples like, quote, "Of course not, I'm not an astronaut, so it's impossible to experience the sphericity at all." After students gave their distance estimates for the cities in question, a simulation was run that calculated Great Circle lines versus straight line routes and compared their answers. The results were that participants who had never personally experienced Earth as a sphere, quote, "failed to demonstrate a concept of the Earth as a sphere when indirect measures such as estimating large distances were used. When such higher cognitive processes were required, they based their estimations on a simple cognitive concept, that of a flat Earth." Thus, even though every single participant believed Earth was a globe, those who felt they had no personal experience of such still retained a cognitive model of the Earth as flat. Or in other words, without a head full of globe Earth propaganda, people intrinsically see, experience, and mentally model the world as flat. 47. The HAL Science Archive features a document created by aerospace researchers in 2011 called "Continuation from a Flat to a Round Earth Model in the Coplanar Orbit Transfer Problem," attempting to minimize the fuel consumption of satellites. The document introduces a new approach, quote, "considering a 2D flat Earth model with constant gravity," which the authors claim can be very efficiently solved and leads to a very efficient algorithm. In their concluding remarks on page 25 they state, "When studying the problem within a simplified flat Earth model with constant gravity, the optimal control problem can be explicitly solved, and the solution leads to a very efficient algorithm that does not need any careful initial guess." 48. In a document published by the Chinese College of Aerospace Science and Engineering in 2012 titled "Design and Implementation of Flight Visual Simulation System," researchers attempted to construct a 3D flight simulation model controlled by real-time calculations. In their mathematical modeling for the flight simulator, they admit that their equations were greatly improved by basing their math on a stationary plane Earth. On page 3 they state, "Flight motion simulation effect can be greatly improved by two assumptions. Flight area is the space above ground level where the rotation of Earth and the curvy motion of mass center of Earth are neglected." If Earth was actually a spinning sphere, surely neglecting the curve and rotation would not greatly improve their mathematical models. 49. A U.S. Naval Research Laboratory report published in 2014 titled "Simulating Aerial Targets in 3D, Accounting for the Earth's Curvature," began with the words, "Most dynamic models for target tracking are derived for a flat Earth," and claims that, quote, "This paper demonstrates how most nonlinear 3D continuous time flat Earth dynamic models can be easily adapted for use on a curved Earth." The document then proceeds to show how convoluted such a process is due to Earth allegedly being not just a sphere but, quote, "oblate spheroidal, only approximately ellipsoidal," and then claims that the actual, quote, "shape of the Earth as defined by the geoid is a hypothetical surface of equal gravitational potential defining mean sea level." They proceed to map their equations onto a smushed globe model while admitting on page 14 that the flat Earth equations are good approximations to the curved Earth result. so their results are barely changed from the flat Earth assumptions anyway. And then they admit the same for travel times around their supposed geodesic curves on page 15, stating, "Nonetheless, the flat Earth Euclidean geometric approximation for the travel time is a reasonable approximation." In their conclusion, they then state, "The limiting factor in the approach appears to be the accumulation of numerical precision errors over time, resulting in small deviations." In other words, their attempt at modeling their, quote, already good flat Earth approximations onto a curved Earth, in the end, still remain mere approximations. Maybe that is the very reason why, as stated in the opening line, quote, "most dynamic models for target tracking are derived for a flat Earth." 50. The U.S. Federal Aviation Administration published a paper in 2015 entitled "Derivation of a Point Mass Aircraft Model Used for Fast Time Simulation," describing guidance control laws used to control an aircraft's speed during descent while managing the aircraft's altitude relative to horizontal and vertical reference profiles. On page 7, in the chapter on reference frames and equations of motion, the document states, quote, "Assuming a flat, non-rotating Earth, an initial reference frame N is defined with the N1 axis aligned with east, the N2 axis aligned with north, and the N3 axis pointing up from the Earth. Considering that on a globe, up is not one uniform direction, but rather changes up to 360 degrees depending on the position of the observer, the complex equations for plane flights that follow in this document, along with all previous listed documents, should not be able to assume a flat, non-rotating Earth."